Hello everyone, we are checking the system in here. It's 1 minute to 2 o'clock Central European time, and I can see people are coming into this StruSoft webinar, so we're gonna wait a couple of seconds more to get the last attendees joining today. We have quite a big interest for this webinar. Very happy to see you today. If you haven't got a cup of coffee or tea, you have still a chance to do that. We're going to start in a couple of seconds. Yes, so I hope you are sitting comfortably and you are ready to enjoy our last StruSoft International webinar for this year. My name is Daisy Slava and I'm connecting with you from Aalborg, northern Denmark. As you can see from the hat here on the screen, we are quite in a Christmas mood, and I would like to welcome you to this Impact Revit webinar, where we're going to talk about modeling of double wall and Formslabs. Today we're going to cover topics which I guess are very interesting for you that specialize in this kind of precast elements. What you're gonna expect today is that we're going to see how we draw a form slab in Impact Revit. Here in the picture you can see that we're going to find out how the definition works, how we set it up, how we can draw a hole, end stops around the hole, end stops around the edges, and we're going to draw additional lattice girders. Once we do it, we're going to go and see the modeling of the double wall. And here I've taken an example of one T connection, which could be quite a tricky task for a 3D modeling designer. And I'm going to show you how to do the connections between the double walls, how to adjust separately the height of the panels, switch the priority of joints, which panel goes by another. So a lot of, I would say, essential knowledge when we do the 3D modeling in Impact Revit. Once we have done with the modeling, we're going to save the elements to the database, make production drawings automatically based on the templates. We're going to see how we do it. And in the end, there is a time for questions and answers. And we're going to see how our elements look in an IFC file. And I suggest that we just jump in and start with the first point, that's the Formslab modeling. And here I have made some points that's mostly for myself, so I remember to show you everything that I think you must know when working with Impact Revit. We jump to Revit now, and in order to make this session as dynamic and interesting as I can for you, I've prepared some underlay. I've opened an Impact Revit project, of course, and I have here inserted an underlay imitating a real life situation in your drawing office. Probably you want to use some, let's say, DVG file, which we can switch on and off. And the plan today is that we're going to draw form slabs in those 3 areas. And afterwards, we're going to draw a double wall underneath the form slab, so we can, in the end, experience some collisions and try to solve them with the help of Impact Revit. So let's get started. We start with the form slab. I'm going to switch off the underlay now, because when you draw a form slab, any kind of slab, then you probably want to have some areas, and I really like to have control over my area, over my boundary. So what I do is that I do some model line. You can do it with the help of Revit just a pure Revit, draw some model lines that you can see as just answering to the boundary. And here we want to draw a Formslab. Now, if you go to the Impact tab, here is where you can find the Formslab. So it's the fifth element, which you can see here in the Impact tab. And here it's worth to remember that the Formslab is sharing a falling menu together with the pre-stress Formslab, the slab, and the pre-stress slab. And if you go to this falling menu, you can see there is one button called Slabs. And here you can find all the four kind of slabs that we have in Impact, right? We have the slab, the Formslab, and their relative pre-stress versions. Everything in Impact, also in Impact Revit, would start with the definition. It's really great to invest time in a good, in a definition that you go through with a well documented parameters in it. What do we mean is that if we go in here, we can see that's how the Formslab definition looks in Impact Revit. And if you've worked with Impact before, could be Impact AutoCAD, then this looks quite familiar because we keep the threads and our definitions come from the database. So the tabs that you're going to see in here, and you've worked with Impact before, well, you know them pretty well. But for the ones that have never probably worked with Impact, just want to see how it works with Revit. In the first step, we have a very essential data about the geometry. We have the width of the element and the slab thickness, which is 200 millimeter. That's the slab thickness of the Formslab. But the base, the concrete plate itself, it's 50 millimeters. This we're going to use later when we want to simulate a full thickness in Revit. I'm going to refer back to that. Then we go to the lift, and here it's worth saying that in Formslab, in my case, I don't have a physical lift family, what means that I'm doing some lift markers. So I want to mark on my drawing where you would like to lift the slab in the lattice girders. And how the marker looks, we're going to find out in a while. It's worth saying that in Impact 17, we have made some additional settings for extra large elements that you can see in here. So if you produce this extra large element, and what is an extra large element, right? This is defined in your producibility settings. You have a possibility to define a way of lifting them. And it's in here also in the lift tab. If we jump further to reinforcement and mesh, these are the two tabs that in the first one you want to, if you take it on, then you have a reinforcement in primary or in secondary direction. And in a case that you want to use a mesh, you're going to do the settings in the mesh tab. Here I'm going to use a mesh, and here there are some previews of the setting that are going to help you set the cut and the cover in the case of the mesh. Let's jump to lattice girders. Here you define the lattice girder family. So like a lot of components you're going to find in Revit, our lattice girders, there are families. And in this particular case, I'm going to choose the lattice girder that is a double support. And here you can either set a number of girders per element, which I've set in here 4, or you can just set a maximum spacing between them and make some settings. Now, these settings in here, it's while we're on the lattice girders, I want to mention something about the settings, and I think it's easier to see it if we just look at here. Here we are in the lattice girder tab, and you can see these settings are quite useful. Minimum distance and maximum distance to short side. In this is a top view from Slab, and here you can, if you do the settings, you can help Impact decide how to place the lattice girder when the geometry of the slab changes. So in this case, I need to have the short side is this one, the long side is, yeah, the long side, and we need to place in this definition the lattice girders 100 to 300. That's how it needs to look, and where it cuts, it depends actually a lot on the family. We're going to see that in a while. Minimum distance to hole, we are also going to see how that it works. So if I have a hole, I want to have a minimum of 50. And this setting we set in the definition, right? And this we have distance to long side. The long side, it's here. We have 300 in the setting. Okay, there is a lot of formulas and calculation going behind the scenes when we draw Formslab. And we're not here to talk about them because it's quite time consuming, but I want to guide you in finding, if you're interested, more about it. So if you go to our Impact Wiki page and you're interested in how we work behind the scenes, how Impact work behind the scenes. So try to see here. We have, if you go to Impact for Revit in the Formslab, so here you can find a lot of information. For example, formula for placing lattice girders, the thing we just talked about, parameters and formulas explained in here. So if you're interested, please visit our Impact Wiki. Yes, but we go to the edges, and the edges, it's just the way it looks on the between the elements. There we want to have a chamfer, right? It's just a diagonal cut on the edge, which in this case we define as 5 millimeter. And the other edges, that's all other edges than between the elements. There we have fine. That we define in the definition, but you can always change when drawing. Then we have the insulation, which we don't use in this example, and the naming, that's parameter for the database drawings in the database. And here ends the boring part about going through the definition, but I think it's important to have this in place because we're going to refer to it when we're seeing drawing the Formslabs. And it's time now to draw. If you want to draw a Formslab, you're going to go in the following menu and start the Draw Formslab, which is the third one from the top. And here, first thing when the window opens is to decide where you take the definition. To avoid any confusion, I have only one in my project, the one that we just looked at. There are some settings about the placement in the Revit model, like we place it when we measure to it, we measure to the bottom or to the top, if that's what you need. And here, if you remember, we had a mesh in our slab. And if I just stop the process, I just want to show you something in the definition. This sign, let's go to the mesh. This sign here, you're going to see a lot through the definition. And it means that all those settings that you set, they are set for the definition, but you can also manually change it when drawing. But Impact is going to help you because when I draw a Formslab now, I select my definition, it's automatically going to fill in. It's automatically going to fill in the settings for the mesh, for the reinforcement, if that's what we're using. And I can see here that I made some settings for the lattice girder, which I don't think that's what I needed, and I can just take it. You can see here I didn't remember to change back because I want 4 lattice girders and a spacing of 300 to the long side. Okay, so it's a very good way to control your definition. If we select it, you can see my lattice girders are the correct family and there are 4 per element like I wanted in my definition. Now, if you want to draw, there are 5 ways to do it. You can pick a structural floor. If you have that, let's say it's a Revit model you have. My personal favorite, pick model lines, which I think it gives a lot of control over your design. You can draw just a rectangular, pick points in closed area if you have a very good structural model with the closed lines around, or you can pick points. I'm going to start with pick model lines, and here are my model lines which I prepared. I press, I pick them, and I say finish. Now here you can see automatically we get a preview of what we're about to draw, and Impact is going to show you how our slabs are going to see to look. Here we see we have a slab that is called a partial slab. It looks good for me. Now I can add some degrees if that's what I want here, right? So it's going to come diagonally, but that's gonna be not appropriate now. I can go to edges, and here, if you remember in the definition, we said that other edges we want to be fine, and that's what Impact shows us now. But you can always change that. So with the help of previous and next, you can, now we are here, and I can say that I want to have a chamfer edge on this part. And if I say next, so here we have a fine, that's okay for me. And support length of 80, it means I go 80 millimeters behind or above the model line if my slab is standing on a supporting structure like a wall. And here we have a fine, but I want to change it to chamfer. And this one also looks fine. Here you can go up and down and change the partial slab position. But for now it looks good. I say okay, and Impact is inserting slabs for us. So let's see how it looks. I'll jump to the 3D view here and control what we've drawn. Okay, and if you remember, I talked in the start that we don't have lifters, but we're going to lift in the girders, right? Here are the lattice girders, but I want to mark where I'm going to lift. In this case, that's the marker. That's the lift family, which is a Formslab lift, we call it. Now, before going in editing, I want to draw the other ones. Now we are on the draw topic, and probably I'm going to go and say draw Formslab. Okay, and this time let's try pick points. So if you're on the underlay switched on, or you just have a model lines, you can just pick like this. What's important is to end the same way where you started. Okay, and here probably it's good to show you this pick insertion, because I can see it's quite a difficult shape in here. That's not so good. So I can pick the insertion of this slab So I say to Impact, start inserting in here. So you get 2 partial slabs, right? So you get one partial slab that is 1801, and the same in here. And in this way, it looks very good, because then I have this recess, which or hole, it's called, which we're gonna just draw in a while, just in the middle of a slab, which is stronger than being on the edge. Okay, so I'm going to insert those ones, and we have only those in here before we go to the edit mode. Okay, and let's just fastly draw the other ones. Gonna pick the model lines again, because then you can also do this. You can just cross select, right? Like this, cross select, you press on finish, and here is my preview. Let's control the edges. We have fine everywhere, but here we need a support length of 80, right? So we should not forget that. So we have a support length of 80. And here we have 80 again, which I don't think it's necessary, right? So we're gonna put it on 1. Yes, and how the partial slabs looks like is that I can just show it here. You can just go, yeah, and move it. You can see it moves up and down. But here it's okay to be in the middle, and I say okay, right? So we have the Formslabs. Now we can go and see them in 3D, of course, and do some editing. Let's see how it looks in 3D. I'm going to jump to the 3D part. Here it is. Here we have our slabs, and we start the edit command, because you can see I've said 4 girders, but probably too much for this one. So you can edit that. You can go to edit Formslab, which you can find here. Select the slab, right? And just write 3. And try to see here, when you edit, we can scan the edges and tell you what kind of edge do you have. And if you remember, in the definition between the elements, we had the chamfer, and this is between the elements, right? This is here. So that's a chamfer. Okay. And then we get 3 then we get 3 girders. Can we see a chamfer here? Can see it. Probably it's the detailing that we need to change. Okay. But we've edited girders, and according to my list with features, we need to go in here. It's the presentation that I want to show you now. Now, let's take a look at it here. What we see is the concrete plate and the girders. If you go to the Edit Formslab again and select a Formslab, then you can see that we have 2 options here. If you go to show full thickness, then you have a possibility to, you can see here, show a frame around the slab, which will refer to the full thickness of the slab. And this is especially useful if we're going to do some detailing, like in a while, and we want to see, well, where's the top of the element. So this is just a frame around. But what you can do is you can also go to Edit Formslab, right? And this time I want to select this one and say Edit, select this, finish, and show in situ concrete is actually going to insert a family on top. So we're going to simulate the concrete that's going to come on top of the Formslab. And this you can use if you're doing some renderings or you want to simulate a finished floor for this building. So it's a very good way to show it in your model. If you want to remove it, you just uncheck it. It goes back to normal, and the same in here. You need, of course, to select this slab and uncheck the show full thickness. So presentation possibilities, very good if you are doing modeling here in the Revit. Okay, now we're going to do some holes, and I had some good ones in here. It's according to my underlay, right? I have some holes that I need to draw, and I'm going to do that with the help of the draw hole command. So draw hole is going to give you 4 possibilities. You can either cut the mesh or keep the mesh, and you could do a hole or feeling. You can do an end stop, so end stop around the hole, right? It's an end stop family. You can cut the lattice girder, and you can either draw using the Revit tools, or you can select, and I love selecting because I know exactly what I'm doing and controlling it. Finish, and I say okay, and now my hole in the slab must be drawn. It's best to see it here in 3D. As you can see, I have an end stop around and I have a hole. And if you remember in the start, we talked that it's important to say to guide impact of how the distance to the host must be in the definition, right? In this scenario, it would be really good to have a very detailed definition, because when this lattice girder needs to be cut, inserting the hole, then impact is going to be guided to the distance, the minimum distance to the hole. When we talk about end stops, let's do some end stop on the edges. That's also a possibility. You're gonna go to the draw end stop command, and here you can either pick points or pick the edge of the slab. So I'm gonna pick this edge in here, like this, right? And here are my 3 end stop families that I have in my standard. You can also choose an offset if that's what needed. And I have the end stop inserted in my Formslab. Now, if you want to edit it, you can say, you can go to edit end stop, right? Select the end stop and probably select the one that is higher. This family is a little bit higher. I'm going to say OK, and then it changes to a higher 150 millimeters instead of 100. And you can do that for the rest of the elements. The same you can do with the hole. You can always edit it. So you can say edit hole, select it, and do the changes that you need. Change the end stop or just remove it, right? Set it to none and say OK. And then the end stop is just going to be removed. We're gonna keep the hole. So editing is an option for draw hole and draw end stop commands. Okay, and the last thing I want to show you before we jump to double walls, that's the lattice girders. I think here it's good to see how we draw an extra lattice girder. The lattice girder is a component that is first of all defined in the definitions here on the components. I have double and single support, and once we have them, we can set them in the family. I can see if I select this one in here, that's the size of my lattice girder, and I can go and draw it, right? I can go and draw the same lattice girder, and that I'm going to do by saying draw a lattice girder in here, and I think it was this one, yeah, 140, and yeah, probably it's easier to draw on the. It's probably easier to draw on a floor plan, But if you need a stronger Formslab, just here, you see you draw it either on 3D or level 1 or the floor plan, and then a lattice girder will appear in the Formslab. If you accidentally delete some lattice girders, let's say we just remove them from here, like this, like that, then there is an option called Update Lattice Girder, which is going to refer to the definition. In the definition, we have set 4 per element with the respective restrictions to the edges and to the holes, and this is what the impact is going to refer to. And last but not least, we have a setting here for Formslabs. So if you go to the first falling menu and say settings, in the general, we have 2 settings, one for Formslab and one for double wall. And we know that a lot of you users would like to have a new element mark for every single Formslab or double wall. You can just check those settings up, and every time you save an element, it's going to have a new element mark. And while we're here, I also want to show you a new setting that just came out with the release. Yesterday, we've made release in installer, and it is possible now to export an IFC file while saving. So you don't need to do it afterwards. You can just record an IFC file for each element once you save it. So you can also check on this setting. And now we have our Formslabs, right? So we can go and check them. And I'm gonna say save. And for this, I'm gonna use the command in the slab falling menu called save slabs. So here, impact is going to scan the element and we're going to save them. While I'm saving them, you can just save them like this, or you can also add an OBJ file. An OBJ file is a very detailed recording of the geometry of the element. And this OBJ file I like to use when I preview the elements in Project Manager. So I'm gonna use that now, and while saving, I'm gonna do an IFC file, and I'm going to do an OBJ file export. An OBJ file is used when we're going to preview the elements later in Project Manager. Okay, so we're saving now the elements, and it's time to jump to double walls. Because what I want to do now is I want to draw double walls under the Formslabs and solve some connections that could be tricky. I want to do that with the impact modeling tools. So if you go to the double wall here, we're going to do a T connection, and we're going to insert this reinforcement that you see in here. So let's see if we jump back to Revit. We're still saving the elements. And let me see if I have Project Manager open. Yeah, so I can actually start reloading and probably preview my Formslabs. It's still loading. So let's wait. Like this. And all the elements are saved. Let's preview them in Project Manager. Yeah, so here what I was talking about, the detailed geometry preview. So once you're here, you can control the transparency, right? And you can have a very good preview of the elements. And later on, when we draw the double walls, we also see some connections in here. Okay, so here we are again on my plan, and we're going to draw some double wall according to our underlay. So I'm going to go to the double wall falling menu, which you're going to find just next to the slabs. And I'm going to click on the definition, a quick review. If I go to edit, a basic geometry settings, an end stop, if you need that and use that in your double walls, you can set a default one. How we're going to use it, we're going to see in a while. Lift and bracing. Now here we have actually a lift that we need to insert. So a definition of the lift together with the um, maximum mass settings for each one of the lifts. Reinforcement and mesh are the two settings that you can use if you want to set reinforcement bars, vertical and horizontal. That's for panel 1 and that's for panel 2. If you want a mesh, then you do that in the tab in here. Here are our lattice girders again. In Impact Revit, we share a lattice girder for the Formslab and for the double wall. As it is right now, we have a single and double support, but I can also reveal that we are very soon going to open for a user-defined lattice girder family. So if you're looking forward to that, you can be happy that it's coming soon in 24. And here it's important to say that we have the settings about the spacing between the lattice girders and the wall and minimum and maximum distance to the edges. Then we have some parameters for the drawing and the database. Okay, but let's jump into drawing a double wall. We're going to use the draw double wall command. And here I just need to control something. I think we draw, yes, so we draw our Formslabs. Here you can see our Formslabs in, we draw them in level 1 at 0. So we need to draw double walls with a negative, negative level. So let's see how we do that. We say draw double wall and we pick the definition. We have 10 millimeters between the walls, right? The gap. And here, take a look at the dynamic picture. We have option 1. So those sides are going through, and then we have option 2, where the horizontal has a priority. You can always change that, but if you know that's how it has to be, then just do it from the start. Then if you remember, we had the default end stop. That's where it appears, so you can switch on and off for right and left end stops if you need that, right? So I say okay, and here I'm going to draw a double wall. First, I need to make, we're gonna start, I say, with the negative offsets. Let's try 2000. And then the slabs were 200. So I think our wall has to be 200. Yeah, 2200. I think it's going to look okay. And then might want to draw it like this, because then I can go with finish face interior. Then I think I can go about the lines. Yeah, I'm hitting the underlay lines. That's good. So I'm gonna draw it until here, and then I'm gonna go down, right? And I'm gonna continue into here, because here I'm gonna do also one wall for the T connection. So like this. Okay, so now we are drawing the double walls, and before we continue, we're gonna see how it looks in the 3D. See if we have hit the parameters right. I'm gonna switch off for the underlay, and I'm gonna go into the 3D. Yeah. Yes, good. So if you remember, we can show the full thickness of the slab. So let's see if we hit it right. I say edit Formslab. I select this one and I say show full thickness because you can see here, I can see that my full thickness is hitting the top of the wall. So that's okay, that's fine. But I have collisions and this I need to solve, right? Because here you can see this double wall is going into the slab. So what I'm going to do now is that I'm going to reduce the height of this panel 2 and I'm going to make a recess in this panel so that I avoid this collision that we get in here. And let's jump into it. Afterwards, we're gonna need a T-joint in here. But first of all, if you select this wall, that's a perfect way to show the edit settings because there is something called reduction for slab. And I'm gonna switch it on and I'm gonna use the 200 because that's the thickness of my slab. So if I say okay, then probably it's a little bit hard to see in here, but if I go and I can make a section, right? So we can see and control how it looks. But make a section and do like this. If I hide all those in the view, and then here it's you need to set it to parts, right? Because then you can see the parts of the wall. Here you can see my double wall. I have made reduction for slab and I have, that's 200, right? The one that we just set. And now my slab is laying on the wall. If it has to go all the way through, probably you're going to also edit the slab length, right? It's just up to you. It's just the idea that impact will automatically lower one of the panel and the lift is going to go down as well, right? But we're not quite ready because if we go to the 3D here, right? So this wall, this double wall, has also a collision. So we are going to need to make a cut in this panel and we can use an impact for that as well. We need to figure out if we go to the 3D view again and let's see it from here. I can identify, probably wonder how you can find out if it's panel 1 or 2. Well, this you can do with the help of the arrows. So the arrows, they're always on panel 1. So that's why we need to go and edit panel 2. But this wall is quite big, I can see, right? So let's split it first, and then we're going to edit the panel 2. How do we do the splitting? We have a command for that. Let's do it fast. We go and on the floor, how's it called, floor plan, and we say split double wall, right? We activate the command. We select the wall and then we pick location. Yeah, I think let's pick this one in here. And now we do this, what impact users for AutoCAD, what is forbidden for them. We press on escape. We do that a lot in Revit. And you can see a lot of things are happening in the background, right? The impact is working. And what we're doing now is that we're splitting the wall and we are um, just using the rules that we have for lattice girders so that we have now 2 walls. You can see them in the 3D and lattice girders and lifts are placed according to the definition. the wall is split, we need to solve the detail in here. So how we're going to do that is that probably I want to treat like this. I'm going to go to edit double wall again. And let's see, go to elevation. You see now this panel is shorter, so we can see the whole wall. But I want to see panel 2, and I'm gonna add, this must be the right edge. And let's say the recess must be 50 and it has to go 200 down on both sides, and it's the top edge. Yeah, so let's see how it looks if we do the splitting. We can see, oh, okay, so 50 is not enough. So I probably want to do some more. If we go to edit double wall, right? And let's see how it looks now. Elevation. Yeah, so it shows me here that I have a recess on panel 2, but I want to edit it. Can we add more, like 100, and see how it looks? Like this. And yeah, Revit is working on the sides. And here you can see now I can avoid the collision because I have made a recess. You can actually see it here. Revit allows me to go through, but what you can also do is make some of the elements transparent if that's what you want. But yeah, I think it's easy to see now if you go in here. Yeah, so we have the cut. So we have avoided the collision. The last thing is that for this particular situation is that we need to solve this issue in here, right? Doesn't look that good. And we have a command for that. And for this, I probably want to use, let's use the 3D. I think that's more easy to see because in Impact, you can Impact Revit, like in any Revit model, you can use both the plan views. You can also use elevations for some of the modeling that is easier. But here I want to use the 3D and I'm going to use the connect wall command. So I say connect wall and I select those two walls. You can just select a single panel. And here I can do some slits, I can do an open hole automatically, or I can go to left or right side. Let's do the right side so we can see it here from this view. And take a look at the dynamic view because here we can edit the parameters and there the dynamic view is updated immediately. The 10 was the gap between my walls. So here I want 200 from top and bottom distance when I do the hole in this wall, right? And I can also include reinforcement, choose the quality and the dimension, the spacing between the reinforcement, the anchorage. Let's do 500 and see the reinforcement bar is also adjusting, right? So it's just adjusting to the values that you type in. Okay, so I think we are ready to press OK. And Impact is working now. What we're seeing is that we are having, we need to include reinforcement. We need to include a gap between the walls and adjust the lattice girders and the reinforcement. But let me see what happened. I think we need, have we selected the two walls? I think we did. Let me do that again. Right side and 400. Now it was 3 I wanted. And the 10 of the wall. And that was 140, like this. So, isn't it happening something? Do I select the walls? They are on the same level, aren't they? Because sometimes if we have the walls on different levels, that could cause an issue. But I think they are. Let's try. If we say connect wall and we take them like this, and we want the reinforcement like this. So the third time is the lock time. I think I wasn't selecting correct in the 3D view. So that's a good thing to remember. But okay, now when we did it on the floor plan, we actually succeeded in what we wanted here is that, yeah, if you see that we have, I'm gonna go to parts, right? So we have reinforcement, we have lattice girder, and we have also managed to include reinforcement. And this is done again with the command connect wall. It can also easily be removed. You don't need to remove each one of them. You can just remove it by saying remove connection. Okay, let me see here. We have done the connect wall and two small things I need to show you before we go with the last part. And I think I'm gonna go here because here is a good example of a corner. And if you remember in the start, I said that you can say switch priority of joint also once you have drawn. So if you have those two walls, let's say, and you want to have the horizontal drawing going by, you can either select one panel at a time and do it, or you can just select both walls like this, cross selecting and take a look. Now they're switching. Now the priority of joint is changing for both of them. And we're also going to adjust the lattice girders and the mesh or the reinforcement in the wall according to the definition. So switch priority of joint, good to remember when you have corners. Switch bracing panel, yeah, we have bracing here in the walls. Probably if we go in wireframe here, right? You can switch panel, so it's panel 1 becomes panel 2 and vice versa. And you can also switch the bracing panel, of course, when doing that. So those two functionalities, good to know if you are doing any changes in the way the double walls looking at. And the last thing before we go further, that's the edit lattice girders. Now, I want to show this on the plan level because that's easier to follow. So let's take this wall in here. If you want to edit a lattice girder, we have this functionality where you can actually see the distance between the girders, and you can draw a new one. You can just draw one here, right? And it's inserted again, not whatsoever. It's inserted according to rules in the definition. But you can also move one. Say this one, we're going to move it in here, and the dynamic view is also updated. Or you can take and erase a lattice girder and then press on escape and add a new one in here if that's what you need. So impact, then you press and close. Impact is just going to add, remove, or just move the girders in a wall going all the way up from bottom to top. Okay, good. So we are there where we're actually ready to save the walls. We're gonna fastly make some shop drawings, see how it works, and we're going to see the walls in the project manager and IFC file. I'm going to cross-select now and go to Save Double Walls, right? And because we have the settings set to new element mark, so we're just going to do a new element mark every time we have a new geometry. And I'm going to say export to OBJ again because we want to see this geometry file working for us in Project Manager. We can have a better preview in the Project Manager viewer. So it's a good tip. It's not must have, but I say nice to have if you're working with the Project Manager. The walls are saving for us. We can see impact is working. And I can say close, and I can let's update Project Manager. And we're going to see them in Project Manager, and we're going to afterwards go to the IFC file and see where we have saved the IFC file. So once we go here, in the Project Manager, we can see the walls, but if you want to see them, the walls and the Formslab, but if you want to see the IFC that we automatically saved for you, you need to go in the components, and here there's elements folder. So once you have done the Formslab, then you can save it, and if the setting is on, here it is, where you can probably, let's try to open this one. We have a double wall. Oh, I don't think it's supposed to go up and like this, but I guess that's a family definition that we need to change. But let's see how the Formslab looks. If you go to the Formslab. Yeah, here it's actually a very good example why you need to take to take a very good look at the office standard and the definition itself, because you can avoid the situations where a component doesn't look correct. But here we have a Formslab, and yeah, I'm using just an IFC viewer, which I have on my desktop. Could be anything that you're using, right? So I use the beam vision, doesn't matter. It's important here to know that if you need separate IFC file for the element, you can switch on for this setting. And the reason actually why we are doing this is because in Project Manager there is a new setting and functionality where you can right click and preview the IFC of each element. That's especially relevant for the cast and air transport units. Okay, good. So I think that we've been all around our let me see here. I think it's time for questions now, if you have any. We've done some modeling, and I'm gonna do it like this. If you have some questions, please ask in the tabs here in GoToWebinar. I'm gonna use the time to tell you that you can use information about impact Revit and generally impact on Impact Wiki, which we've been through today. We are usually also posting a tip of the week on LinkedIn where we come with generally good ideas of how to use Impact for saving time when doing precast. We also have a StruSoft official YouTube channel where you find a lot of our webinars and general recordings, and then our webpage where you can see the upcoming webinars. Let me see if there are some questions today. I have my colleague Thomas here on the in the office, so he helps me reading through the questions. But do we have some, Thomas? No, we don't have any questions. So I guess we are just hitting 1 hour. We can't be more precise. It's 3 o'clock. And I guess now it's time to say Merry Christmas to all of you that celebrate Christmas and Happy New Year. It was really great to work with you and to present for you this year. And we're looking forward to the next year where we continue, of course, with international webinars, and follow our webpage where you can sign up and see what's coming for you in 2024. If you have any questions, please don't hesitate to contact the support or me. And I say thank you for today and see you in 2024. Bye.